discs of different sizes, like this one, 3 discs. Maybe you have plates in your house, you can bring those 3 plates or 3 things of different sizes. Like I have here, these are different size, 1 and 1. Okay, now we would see what are the possibilities of combinations. We will come to this, but before this, I would introduce you to 2 concepts in this. Suppose you live in Mumbai, okay, and there are 4 roads between Mumbai and Pune. Okay, now from Pune to Bangalore, there are 3 roads. Mumbai, see, mathematics is not just arithmetic operations. You are just learning arithmetics, practicing it, how to do faster multiplication, how to do faster calculations, addition, subtraction. Unless you apply it to real life, what is the fun of mathematics? Tell me. Right?
Sir, it's also like people who are in a room and they need to shake hands.
Yes, shake hands. How many of you have watched Super 30? The Hrithik Roshan movie? It was about one, like entrance examination. Okay, no problem.
No.
So this, like Kavi says, the shaking of the hands, that is also one of the applications. So we would go there one by one, step by step. Today, I will take up small steps. Then next class, we will take deeper questions. So right now, the question is, from Mumbai to Pune, there are 4 roads. And between Pune and Bangalore, there are 3 roads. Now the question is, how many options exist from going to Mumbai to Bangalore? How many options are there?
12.
12. Yes, there are 12 options. But how did you find out? That is also a question.
So you just need to multiply. Yeah.
But how did you decide to multiply?
So because there are 4 roads in Mumbai and there are 3 roads in Pune.
Yeah, between Pune and Bangalore, there are 3 roads. 1, 2, and 3. Here there are 4 roads. 1, 2, 3, and 4. So there are 4 roads here, and there are 3 roads between these 2 points. So we say 4 multiplied 3 is equal to 12.
Yes, sir, because there are 4 roads and you can go by any 4 roads.
Yes.
And in 1 road, you can go in 3 different directions.
Awesome. So you say there are 4 options between Mumbai and Pune, 4 options. Can we call it options?
Yes.
Right. And each option has 3 further options. This is why you multiply. Right? So what we are saying, so now between Mumbai and Bangalore, we have 12 options. See, mathematics simplified it this much. 4 into 3 is equal to 13, 12. Very simply, immediately you could calculate. Suppose we don't know this formula, then what we would end up doing? We would say M1, this we would say road number 1. This we would say road number 2, this we would say road number 3, this we would say road number 4, right? This is how, if we don't know this formula, then what we would say? We would take road M1, P1, right? This way. M2, P2.
So we can say M is 1 gate and P is 1 gate.
Yes. So can you list all the formats, all the possibilities here without using the formula? Can you list all the possibilities? Like let us call this is road number M1, this is road number M2, this is road number M3, this is road number M4.
We can be M1, P1, M1, P1, M1, P2, M1, P2.
No. Can you please try to list all the options?
Yes,
we can appreciate that this is great. We know the formula. See, knowing the formula, if we remember the formula, we will forget it one day. Let us derive this formula. Let us derive these formulas, because someday we might forget whether we should multiply or add. Can we derive this formula that particular time? Let us see how many options exist. Like we call it like a layman. We will
Explain
see.
simple thing.
Yeah. Yes.
Okay.
M1.
So if you go on M1, there are 3 more paths. So
That is fine. That is
M1,
absolutely fine.
P2,
What we are
P3.
trying to do is list all the paths in one list, like M1. Okay, this is M1.
P1,
P1. Yes, M1, P1.
M1,
M1,
P2,
P2, M1,
M1, P3,
P3. Awesome. Then M2,
P1.
M2, P1,
P1, M2, P2.
2,
Awesome, right? M2,
M2, P3.
no, M1, M2, M3, and here also right, M2, P3. One set,
That's
two
M3,
set,
P3.
yes, M3, P3. And then third set would be M1, P3, is it?
Yes, sir.
Should I say this?
And M1,
M2, P3.
M2,
so that cannot
P2.
come. M1, P3 can't come because there's already repetition.
It is repetition, yes. But we are just checking one is done with these three. M1 cannot come. You are very right. So can you list all the options on a page and see is our formula right? Make a
I'll
paper
list it now.
and list all the all the options. Let us
So
check if our formula
you
is
can
right.
basically say M1, P1, M2, P1,
Yes.
M3, P1, if there are 4 paths, M4,
Yes.
P1.
Yes.
Then
But let us list all of the options and check if our total comes to 12.
so
That is my
M2,
suggestion.
P2.
Then
Yes.
you write it yourself. I would write here and you also write there on your paper and we will check. Possible? I will check here.
Okay, I'm doing it now.
Let us see
Let's
if we come to 12. Let us see if we come to 12 options.
Sir, actually, this is my first class, so can I know what is
You
it
are
about?
welcome, no problem. Same way, you keep, we want to just cross, my idea is not to remember things. And once you have done making 12 options out of it, you would start appreciating how beautiful that formula is, right? And make 12 options and your option should match the formula. Once you are
goodness.
done, you will never forget this formula in your life. And if you forget, no problem. Let us forget. We can come back to it anytime. And here, no mathematics. Is there
Done,
any
sir.
calculation? 12?
Done. 12.
Sir, it is 12 because from the first gate to the second,
Yes.
there are 4 paths. So if you
Yes,
take one
yes.
part,
Yes.
from the second gate to the third, there are 3 more paths if
3
you
more.
go in the first part.
Yes.
Again,
Your
in the
logic
second
and
part,
your
there are 3
deduction is perfectly right. The way you are deducting it, it is correct. But once you list out all 12 options and see these 12 options match with this, correct. Now, can we do one more option here? Like you have 4 letters, okay? You have 4 letters, A, B, C, and D. Let me wipe it clean. So this is all the paths you have clearly understood now. Now we will clean this one. Now we have reached Bangalore. Finished. This part is done. Now we have 4 letters, A, B, C, and D,
D.
and E. A, B, C, D, E. We have 5 letters. Now the question is, we have to list all the different ways we can make complete words using A, B, C, D.
So should we not list out the things that is already done? We should not repeat.
2 letters.
We
2
should
letter words.
Oh, okay, sir, but we should not repeat it. You can't say
Here,
A, B, and B, A.
no, here we can say all the different ways this can be done, and then we will do different another way.
So there will be
2
15.
letters.
15.
Order is important. Order is important.
So there will be 15.
1, 2, 3, 4, 5. 5 and 2 letter words. Huh?
Yes, yes, sir. So
Can you repeat the same thing twice?
See, like here, you write A, B and B, A are 2 different letters.
And you can
A,
repeat
B?
the same thing like BB?
but then
Yes,
there will be
no, no.
25.
B cannot be used 2 times. A
Okay.
cannot be used 2 times. A, B, B, A, C, C, A. That is fine.
Okay.
2 letters. Just we will make, once we are done listing the options, the formula will start to make sense. We should not be after formulas. We should be after deducting the formula, how we arrive at the formula. Then you can apply it anywhere. And just list A, B, A, C, A, D, A, E. Like that.
I did it. I did it.
There will be 20. Yes, sir.
Yeah, it'll be 20.
Because if you
20.
do,
Awesome.
sir, I can also guess this because 5 5 is 25, but you have to remove A, B, C, C,
Yes.
D,
Because
and
A
E.
cannot be used
So
2 times. This
These
is why.
all will be 5. And
Yes.
if you remove 5 from 25, it will become 20.
Correct. This is correct. Very good. Very good. So now we know this is multiplication, the very basic thing. But even if you forget how to arrive at it, you can derive your formula. And then we will go to complicated exercises, but there is not much mathematics involved in it. It is just use of mathematics, use of arithmetics, whatever formulas we know, we have to apply it in real life. Yesterday, I was watching some YouTube videos with Shashwat. How many of you have watched Mark Rober or Action Lab like that? Do you have any favorite channel?
Yeah.
Sir,
Mark
uh,
Rober. I love Mark.
Yes,
Sir,
Mark Rober I will refer, because in Mark Rober there was a video. You know how many views were there? 65 million views.
My
65 million views. And what kind of videos he makes? It is not music or song or anything. It is science videos, based on physics experiments, that kind of scientific videos he makes. Beautiful concepts, creative engineering. I was thinking, the idea is, I'm not after making you practice your arithmetics, practicing your maths, practicing your multiplications, division. It is applying your maths. So suddenly it occurred to me, 65 million. Okay. If I lay down each man, say one man is 6 feet, 6 feet, 6 feet, 6 feet, 6 feet, 65 million. Can I cover the earth? How much distance it will be if one man 65 million times I keep 65 million views? That means एक आदमी ने एक बार देखा ना. So if I line them up one on the top of another, where we will reach? And I really did a calculation.
Actually, in that kind of videos, they will rewatch also.
That is not a question here. The question is looking for application of mathematics. So I thought 65 million, if I make a tower of people who have watched this, how high the tower will be? 65 million. Or if I lay them on the road, where they will reach?
My goodness.
Imagine,
Where?
can you calculate 65 million how long in kilometers?
no, normally most people, we need estimation for this.
Yes, estimation. Let us estimate one man is approximately 1.7 meters. How many 65 million? How many 65 million?
So 1.7 into 65.
65 million, huh?
Sir, I'm gonna remove the zeros and then I'm gonna
You
add the
do all the calculation. Just let us see how many kilometers it will be.
My goodness.
Now we will see 65 million. How many it is?
Excuse me, sir.
Yes.
I did it, and we should first do 65 into 6, and then we have to
No,
convert
that you
as
do
many
yourself.
feet. Then
All this calculation, you do it, and I try to see. You need input 1.7 meters. Let us say it is the height of a man, an adult person. I just looked it up on internet. I don't
Oh
remember.
my goodness. 1105
How many kilometers it is turning out to be? Approximately, I will tell you. I did this calculation here. Delhi to Dubai is 2,300 kilometers. Delhi to Dubai is 2,300. Delhi to Pune is 1,500 kilometers. If I convert Mark Roberts 65 million, that is 66 million, and he made a trampoline where he throw the car. He made a huge trampoline and they were throwing a car onto it. World's largest trampoline like that he has made, 65 million.
Sir, I've seen that they'll throw watermelons also.
Something like that. 66 million views. If I calculate, it will be 11,000. It will be
11,000.
66 million. When we convert to kilometers, and it will be.
So it'll become 1105 million.
Yes.
So it'll become
116,000. 116,000 kilometers.
My.
Imagine
Please.
if they
just imagine.
116,000 kilometers. And how much is 116,000 kilometers? Delhi to Dubai is only 3,000 kilometers, 2,300.
My goodness. We'll cover the earth.
Almost the circumference of the earth is 40,000 kilometers. What? That's all. 3 times you can cover the earth. Let me see how many times. 116 divided by 40,000. 3 times you can cover the earth.
My goodness. 3 times in people.
If they lay 1 to 1, head to toe, then last class we were talking about the unit Smoot. This is what that guy did. He laid down, like Dandavat, straight, then put a line in. You may have seen this kind of thing in our temples also. They lay down on the floor and then put a line, then go like that.
tape that long.
Yes.
I wish I had a measuring tape that long, but it would go 3 times the circumference of Earth. So you can imagine how utterly big the tape would be. Because you only have let's see, I think 3 meters measuring tape at the most. But if we had 65 million meters, we wouldn't have to go, okay, this is 1 3 meter, this is another 3 meter, this is another 3 meter, this is another 3 meters. You could just measure 9 meters just together like that.
The thing is, mathematics is something that you can do in your head directly. You don't have to walk to a black hole to measure it. You can do all the calculation on a piece of paper. This is the beauty of mathematics, right?
Sir,
you don't
what
need
Mark
any
Roberts
nothing.
squirrel maze.
Yeah.
But this, yeah. So this. Wait, I forgot what I was going to say.
Okay. The basic thing is, if you apply mathematics, if you see the numbers, if you visualize the numbers, then they start making sense. If you say 1 billion views, have you seen any video with 1 billion views? And what if I make a line of 1 billion people, head to toe? It will be 200 and the length would be, I checked what is the largest views. It was 1,100,000,000.
Sir, it's a music video.
Yes, And the total kilometers, how much it will be? 205,000 kilometers. That huge. But then how much is
Again, it is
200,000
asked.
kilometers? That is what
Yes,
we
sir.
should ask ourselves. So when we visualize numbers, visualizing number is important. We can talk about millions and billions, whatever, but visualizing is important. When we say the circumference of the earth is only 40,000 kilometers, that's all. In 40,000 kilometers, this is what, and from Delhi to Pune is only 1,500 kilometers. So when we talk about numbers, visualize it. And visualization is playing with the numbers. Like here we did, 14 roots.
Sir,
With AB and AC, we made those 4 numbers like that. Okay.
sir,
Sir.
like I want to ask a doubt.
Go ahead.
I don't know which mathematician was it, but that mathematician said if you had a big enough lever, you can lift the earth with a big enough force.
I couldn't understand. Tell me again, one more time.
Yeah. So that mathematician,
Okay.
he can lift the earth with a big enough lever.
The problem is, where would he stand? He needed a place to stand and a long enough lever. His name was Archimedes. He was a great guy. And
I know Archimede.
if you are interested, we can make an experiment in one of the class and we can really make the earth move. Imagine one thing. Very good. See, in mathematics is something where you can do all these calculations in your head. Imagine one situation. You have a mass, earth is a mass. That first, let me answer that question. That guy was Archimedes the Great. He was a great earth mathematician. Now, let us take it further. He said, if you give me a place to stand and a long enough lever, I can move the earth. That is one thing. But you can also move the earth. Earth has a mass, right? You have a mass. How much you have? Maybe 20 kilo, 25 kilo, 30 kilo.
18.
Abhi, what is your weight?
I'm only 18.
33.8 kg gram.
23.8 kg, because he has a weighing machine and he is measuring everything. After eating, he weighs. After going to the toilet, he weighs, and how much he did. He has a chart. Everything is recording these days. How much food, how much this? So 25 kilo. Earth, if you go up and jump down on earth, will earth move or not?
No.
That's the question.
Absolutely.
What is big?
There's a
If you cannot measure it, that's your problem.
sir, you can't measure it, but there's like a small formula for this.
No,
Like
not the
you,
formula. The very
the
basic
distance
idea
of
is,
the
if you
levers.
jump up and you jump down on earth, on a table on which you are sitting, will the table move? It will move significantly.
Sir, the thing that would happen is that you'd simply become an utterly besmirched fired ball because Earth has an atmosphere. It's not like you have a solidified sky over there.
Okay. Now the question is, we can do an experiment. It is a mathematical experiment. This occurred to me. Can we, if we jump up and down, how much the earth will move? Do you want to do this calculation? I'll bring that worksheet and we will do this calculation. This idea occurred to my head and I really did that calculation. How much earth will move if you go up and jump down on earth?
What if we have a million people jump down up and down at
what
one
will
time?
happen? There is a book called What If. It is a beautiful book. I don't have it here, but it is a beautiful book. The name is What If. If you can find somewhere, read that book. You will go crazy looking for looking at the questions there. What if we put all ants' brain together? Will it be more than human brains? What are you doing? That kind of question. This was one of the questions
Sir,
there.
the answer for that is all ants' brain together will make only one brain of a human being.
Yes, very right, very right. So these are the questions. So now this Archimedes thing we will do some other class definitely.
Sir, the thing is that if we look at the answering question, if we so first you need to know how many ants that are on it.
That
It's
that
not
all
like you just hear the
calculations
part,
can be done. Yeah. Yes.
and then you have to calculate how many species, how many ants per each species, how many representatives on each subcontinent. You have to do a precise census for these ants, and these ants are getting born every time, and then the other ants are found in new ant colonies, and then those are and then so on. So it's very difficult to answer that question.
Yes. So
then
right
you
now
have
the idea is to use mathematics. That is the basic idea. Use mathematics. Come up with your own questions and use it. This Archimedes question is very valid. Yes, it can be calculated. And this guy said, if you give me a long enough reader, I will move the earth. That was it. And if you jump, the earth will move. How much it will move? It is not a measurable distance, but it can be moved. Now next is the same thing here. What we are seeing is combinations. How many possibilities exist, right? Now, one more thing we will do. Suppose we go to a restaurant. Okay, we go to a restaurant, and in the restaurant we are giving 3 choices. Like the options are 1, say starters are 3 types. 3 types of starters, 9 types of, say, main course, and suppose 4 types of desserts are available. How many choices do we have? The same thing, the one that we did earlier. 3 starters, 9 options on the menu for main course, and 4 for the dessert. So how many total choices we have?
Just multiply it.
Yes, how much? And the result would be mind-boggling. See, you in a single restaurant, that many choices are made available to the customers. Multiply and see how many, how much it is. How do you multiply?
It is 3 into 9 into
Yes,
4.
27
It
double.
is 27 into 4. That's
And how do you multiply 27 into 4? Better multiply double and then make it double.
Yes,
It is
sir.
quicker, right? Do it. How much? 25, 27
54.
double is how much?
54 into 2.
Yes,
It is
54 double.
108.
108 choices.
108.
108 choices.
So,
Kitna khana hai yaar? I will go mad selecting it. 108 choices. Only out of these 3. See how many choices you have.
100 choices.
Yes, 108 choices. And if you go to the restaurant next time, and when you are looking at the menu, your father will say, order something. He would not know you are calculating the number of options available. Right? Next time you are in a restaurant looking at the menu, this mathematics would be playing in your head. How many choices? How many desserts? How many sabji, raita, and all this?
So what was the number of dishes available in that restaurant?
It came to 108. We multiplied simply. See, once you are done, 108, yes.
Right.
But when you are in a next
you would
restaurant, yeah, you check how many options are made available to you. You would be surprised. This is application of maths. So when you are in a restaurant, look at the possibility that how many options are there. Now you have a combination lock, okay? In a combination lock, you have 4 options, 0, 1, 2, 3. 4 position. Do you have, anybody has a combination lock somewhere in your house, the combination lock part of it? The combination lock where there is a dial here.
I have
Yes,
one.
sir.
I don't know where it
I have one right here.
Okay.
lock the bike.
I
I
have
have
right
one
here.
lock and then you move it.
Now-
But I don't have it right
Sir,
now.
I have one
Okay,
right
no
here.
problem. How many digits are here in your lock? 4 or 3?
Sir, this digits up to 9.
No, digits
no,
is,
but
here
on
it is options are 0 to 9. Very right. He is
Sir,
right. 0 to 9.
Sir, so
but
it's
it's a 4, like
9
1, 2,
cube.
3, 4, and then you can like
Huh,
make
4.
your
1,
Sir,
2,
it's 9 cube.
4. Okay.
So it's 9 cube because
No.
9 into 9 into 9.
Yes, very right. But now hold that formulas. We are not after formulas. We are after deriving the formulas. So when we have to steal somebody's bike, we have to calculate how many seconds we need. See,
Sir.
I want to steal her bike. And it only has one option, one lock. Huh? So how many options I have?
9.
If I try,
Nine.
so you may have chosen 3 or 4. So I will try 0. It opens fine. 1, it opens fine. 2, it opens fine. But out of 0 to 9, 1 will be right. So 9 seconds I can steal her bike. Now come to next. Now you have 2 positions, 9 and 1 more, 0 to 9. Now how many positions?
81, sir.
81. So 81 seconds.
Okay, now
1
see,
minute.
now you have 3, 0 to 9.
So then it will be 9 into 9 into 9.
You say
9
9 into
81
9
into
into
9.
Now you have 4. Calculate how many.
Okay, wait. You can do 9 into 9 and then 9 into 9 and then you can do 81 into 81.
Sir,
9
it's
into 9
729 is a 9 cube.
How much total?
729 is 9 cube in 3. 9 cube. And then
How many? We have to steal her bike.
Sir, 729 seconds.
We are plotting and convert it into hours.
Sir, 7,361 seconds.
How many hours, beta? We need to plan for it. She will return in maybe 10 minutes,
Oh.
15 minutes. How much time she will eat in a restaurant? Her bike is parked outside. We have to steal. Can we do it in half an hour?
Mine says it's 6,561 seconds. So then,
Hours?
Mostly to 1 hour or 2 hours.
100
So
minutes?
first, we need to divide it by.
Yeah. Calculate how much. How many
We
hours
first
it
need
is.
to divide it by 60, and then
I
again
think I
60.
could do it in 90 seconds.
Each move in 1 second, how many it comes? Approximately.
Okay, so now you have to pick her lock. Or you have to unlock her thing. And then you have to roll it away into some sort of a safe place where she can't find it.
No, that is not in part of a question. The total is how many possibilities, how many options.
I'm still doing, sir, because first I have to divide by 60 and
Yes, divide by 60 and divide by 60 again. That's 60 minutes. And then hour. How much it is coming to? This is
2
using
hours, 2 minutes, 41 seconds.
2 hours. Nobody can keep her busy for 2 hours.
0.2
She will come and catch you and over to police.
0.2 hours. Not that much. It is 0.2 hours.
And
No, then you say,
Now.
oh, I thought this was my bike. Oh,
yes. No, that ideas you keep. You can't make fool of her. Forget it. If you can do it in half an hour, you can run out.
it translates to 2 minutes.
Yes. So it is impossible. So using mathematics, we just dropped our stealing plan. We will not touch her bike at all. But here you have made a mistake. It cannot be 9 multiply 9 multiply 9 multiply 9. Imagine, once you are done with this 9, okay, when you are done with this, here
Sir,
the options are
I
9,
know.
fine.
sir, I know a trick to open any lock.
No, beta, this is not relevant question. Now we are talking about something else. Yes, you can open any lock. Very good. We will have a lock picking class someday. But we have taken 1 second to tackle one move. That is enough. Huh? 1 second can't be faster than this. See, here the options are 0 to 9. But next, once here it comes 0, then here 9 again.
If it's 0 to 9, that means it's 10 digits because 0, 1, 2, 3, 4, it's 10 digits. So instead of 9, 9, 9, we should have done 10, 10, 10, 10.
Yes. Now, one more thing I have asked you. This we will take further. Huh? Now we have calculated that if we have 3 possibilities, we can multiply the. This is another thing. We will talk about it. We will take it in another class and we will build further on it. For now, we already know that if we have 3 menu options, one followed by another one, we can multiply. If we have 2 points, Mumbai, Pune, Bangalore, we can multiply and we can know how many options exist. We will stop this one here because then it is a lot of work here. Huh? But not mathematics here, not much mathematics. It is application of mathematics. So it is not knowing how good you are in your formulas or your multiplication tables. Leave everything. Apply mathematics. You are in a restaurant, apply mathematics. You are opening your combination lock. Try opening, listing out all the options and you see, oh, can I drive a formula from it like that? So my encouragement to you is, when you come across an opportunity where you can use mathematics to solve problems or understand life, do it. Whether it is restaurant, whether it is bike combination lock and everything. This lock we will discuss again. And this is not right. 9 into 9 into 9 is not right. We will take it next level. Okay. Next class we will do it. Now enough of real serious mathematics.
But if we do 10 combination log, this is the answer.
Yes.
That's great. You can just carry away the bike and then you can try out the combinations in your house.
Yes, all options. Now, one thing I would show you that will make you interested in the subject of possibilities. This subject is called combinations. This is called combinations. How many combinations are possible? Now, if you can get 3 different size of discs, like I suggested you last time, like 3 plates, can you bring 3 plates?
How many?
3 different size of plates from the kitchen or wherever you have, or 3. Yeah, 3. No, not color, any size, but they should be 3 different sizes. Like I have 3 here, 1, 2, 3, like that.
Okay, sir. Sir, I have
Keep any 3 discs and make 1, 2, 3 positions. Don't have to have the pegs, just 3 positions.
Sir, I have a 10 one.
Keep any, or maybe you can cut small papers and you can do it. See, the subject that we will be discussing is combinations. How many combinations are possible? This you will find a lot of applications in lotteries. This is there in restaurant menus, in combination locks, in exam papers. How many kind of exam papers we can write? How many number of letters we can write? In number theory, it will find application. Here, the issue is this one. You have 3 sizes of disk, 1, 2, and 3. They are smallest at the top, then larger, then larger. Okay, now we have 3 disks. The idea is to transfer from here to another peg. Okay, the rules are like this. Small here, then it is smaller, smallest. So the bigger one cannot go on the top of it. Bigger one has to go somewhere here. This is bigger. Now this can go here. But now if I have to move this, I cannot put it here. I cannot put it here. I have to move this one. Now this is the largest. It cannot go down. Now how do we do it? Take 3 disks and try the combinations. How many moves does it take to move these 3 here?
Sir,
Just try with 2 and 3.
sir, can you tell the rules again?
Okay, the simple is, say you have one, only one. You have one,
Yeah.
you have to move it here. You can move it here because there is nothing smaller than this. Okay, and we are
Yeah.
picking one. So one, if you are moving one, the answer is 1. In one move we can move. Now we have 2. Take 2. You have 2 discs. Keep 2 here. On your left, you take. Now we have 2 discs. Now we have to move to another one. I can move only one at a time. I moved one. So move number 1 is complete. Now move number 2. This has to move, but I cannot put it on the top of this because it is smaller diameter. I must put it here. 2 moves gone, huh? 2 moves are gone. Now third move is this. So when you were doing 2, it took you 3 moves. Now try doing it with 3. Okay, now the fun starts. Try doing it with 3. Try doing with 2 first. Can you complete it in 3 moves? Any 3. Try doing it with three discs. Now, smallest on the top, then larger, okay? The smallest, I pick smallest, keep here. Smallest here, but now this cannot go here. One move is done. This I pick.
Sir,
I have to keep it here.
Sir, I did 11 moves and I got all 3.
I did 7 moves.
7 moves for 3?
3.
Okay. 7 moves for 3.
I got 11.
Then you can do better. 11 is not right. If it is 1, then it is 1 move. If it is 2, then it is 3 moves. If it is 3, then it is 7 moves.
Can I like show how I did it? Like in what
Yes,
order?
7 moves is perfect. You are right. 7 is the answer. You cannot do it in less than 7 moves. If you can do it, if you can somehow do it in less than 7 moves, your name would be on the front page of New York Times, India Times, every times, double times. Try doing it in less than 7 moves. You cannot. At least this is what we have, but there could be a way, I don't know. If you do it with 4, can you try doing it with 4? If you try doing it with 4, it will take you 15 moves. 4.
So if we try it out with 100,
We will get there. We will get there, beta. You will.
You said in last class you said that like from if you have the 64 of those plates,
Yes.
it will take like from, because you said that in one
I
temple.
can tell you the time now. I have my magic formula here. I can tell you the time. Tell me how many moves.
64.
Okay. 64. Okay. I will tell you in years. Huh?
Okay.
It will be.
Are you using Excel?
I am using Excel. 584 billion years.
Yes.
584 billion 940 years.
So if 64 is that much, then 100 will be like even like
That is not even the age of the universe. Okay, 584 billion years. And life came to Earth around 3 billion years before. We are talking about 584 billion. How it is possible? This is where it comes. How do we arrive at a formula? Not remembering the formula. Don't try to remember the formula. See, you did 1 in 1 move, 2 in 2 moves. I will share my screen and you can see the, why not? I will show you an animation for this.
So one thing, so
Yes.
you are saying that we have to move the biggest one to the end, that one, right?
Yeah, no. See, you have 3. Okay, the idea is very simple. You can play with it. See, as you have 3. 1 is biggest, then you have smallest, then you have this 3. big, smaller, and smaller. Now you have to move it to another peg. There are 3 pegs. There could be more pegs, then the game becomes more complicated. We are using only 3 pegs. So smallest you move, because now this has to come on the top. So we will keep it away, sort of.
Yeah.
Now the biggest cannot come on this. Larger one cannot be placed on the top of smaller. So larger one, where it will go? To the empty one, right? You can place 3 positions. On the floor, you can do it. Now this is larger. Now larger, this cannot go on this. This cannot go on this. So this smaller one, you will move. Now it can come out.
I'm just using like paper that I cut in.
Yes, you can use paper, cardboard, anything. Mathematics is the easiest and cheapest hobby.
And okay, so you need to move all 3.
All 3, but you can move only one at a time. That is the condition. And you cannot place a bigger disk on a smaller disk. That's all. These 2.
Those are the okay.
These are the 2 conditions. And once you do it with one, you can do it straight away. Like you have a 1 disk, you can straight away keep here one move. Now you have 2, 1 and a smaller one. Now we have to bring it here. So it is 1 move, but this we keep here, 2 moves and 3 moves.
Yeah.
Try with 10. You will have so great fun. But you should have patience.
I did 3. I did with 3, and I could move the biggest one to the end point with 6 moves.
Then you made a mistake somewhere, or you are a genius that we have not figured out yet.
I did with 6 moves, I'm pretty sure.
Then record that, put it on YouTube. 65 million views are waiting for you.
No, seriously, I did it with 6 moves. So, how did I do it?
Record. We have a genius in our hands now. 65 million views. See, 3 moves. 3 cannot be done less than 7.
Sir, for 4, I got 27.
4, you can how much?
27.
27 you did it, but it can be done in 15 moves. Now I will tell you how it is done. Okay, I will show you an animation and we will play there. This animation link I will give you so you can play to your heart's content. Okay, I'll show you an animation. I will share my screen with you. First, I should have bragging rights for my data sheet also. I should show you data sheet how I made it. Okay, I will first share my screen. Okay, we will take one class. I was thinking of one thing. Why not we have a class where we start doing Excel every day, small, and reach here. Okay, I will share my screen. Advanced.
This time I did it in 4 moves. What is happening?
No, but maybe you are making a mistake. 2 things. One, only 1 disk has to move. Second, you cannot place a bigger disk on a smaller disk. 3 pegs only.
I did follow all of those.
No, smaller you cannot put on bigger. Maybe there is some error. And now you see the animation, you would understand what it is. Okay, now I will share a screen.
Wait, so I think I realized how she did 4 moves. I think, see, so if you have one paper here, like all of it like this, and then you move the smallest one to the the second peg, and the medium one to the one after that, and then that's 2 moves, right? Then you just move the medium back to the big and the small back to the medium. I think that's what he did. Then
maybe there is some error.
No, I did something else actually, and I'm following all of the rules. It just somehow.
Okay, that is fine. That once you see the animation, you would gather what it is. A complicated thing. Why I like this is mainly because there is no mathematics in it. There is only logic and reasoning. I am always after exercises where more of logic is there, more of logic and less of mathematics. Where is my animation? Oh. Okay, 1 minute. I will show you. Here
So I'm trying with 7 pegs.
This is very ambitious and this is what we should, if you really start playing with it, formulas will stop to matter, Okay, here it is. Now I will share you the screen. Where is the Zoom? The screen. Just 1 minute. Let me share the screen, how it is done. Advanced. Share. Okay. Are you able to see it here? The screen?
Yes.
Do you see these discs flying?
Yes.
Can you see it?
Yes.
Okay. Now, this is the tower. Now you tell me how you want to start it. Should we start it now? We start it now. We are starting with 64 discs. See. And it will take how long? It will also give you the time. 13 moves made, and here is the time. You see the time, 18 quintillion 446 seconds it will take to finish if you start the game now with 64 moves, 64 plates.
My.
Share the link for this one.
I will share the link. You all can have the fun, and this is how one falls in love with mathematics.
Is
This
there
is how
in this one where it won't move, like you can move it, or will it move?
No, it is moving on its own.
Sir, are they supposed to watch this for 18 quintillion?
Then it will be complete. No, you are not supposed to do anything. If you love watching, you can keep watching. If you have nothing better to do, you keep watching. But now here are options. Look, an hour ago, I will say this started 13.8 billion years ago. What is the condition now? Okay, can we do it? Suppose this game is starting now. It will take when? It will take 18 quintillion seconds. Right?
Sir, can
if
you
we
please
start now.
mark the Big Bang? Sir, can you please mark until the Big Bang and?
Yes, this is what we will do. Now,
Yes, sir. If you say Big Bang, it'll be.
Now there is an option. So we start this game not now, because now we have to wait. Suppose this game has already started when the Big Bang happened. Why? We will start in 13.8 billion years ago. We are very close to doom. See here, it is about to finish. This much is already done. Now I have selected 13.8 billion years ago. And I'm sharing the link with you. You all have fun and keep troubling your parents and your brothers, sisters. Sab dekhenge.
There's one arrow mark, right? What does that stand for?
No, this is the end, like whatever. Now you see here.
Oh.
This is the one. This one, the arrow mark is the main body. It has to be transferred.
Okay. Yeah.
Now, whatever, just travel in time to the end. Now we are ending. The universe is about to end. Last time, smaller. You see the size of the disk. And I will share it in the chat screen. Here you can open. Here, this is the link.
Oh my.
Can you check here this screen?
And it's done.
The problem has been detected and universe has been shut down.
Oh my.
It is endless fun. I can't stop watching it.
The universe has now been terminated. We are processed with inconvenience. Pretty really like that one.
And you see, you start with now, you go to an hour ago, and these are all possibilities, combinations.
how do you change the number of discs?
Discs, number of discs, here there is no option for changing the number of discs because it starts with 64, and it is said that in Kashi Vishwanath temple, I don't know, I never been there are 64 discs, gold discs, and there are 3 pegs, and the priests there, they keep moving the disc physically. It is said, I have read it all over, but I don't know whether they are really doing it. I'm still looking for the confirmation that priests really do it there in Kashi Vishwanath. This is here also he writes the Tower of Brahma and the End of Universe. If you read, you got the link? If you read here also the Kashi Vishwanath temple in Varanasi, that mention is there.
But one thing, I tried the 4 moves thing again and again.
Okay, no problem. I will show you with 3. There is another link. It is much clearer. Okay, you will get it. No problem.
Here, I didn't find anything.
No, maybe I will. You have the link, so I can change the link here. Another one. Here you can change the number of discs and number of pegs also. And this I don't do for the class.
Which
this I do just to keep myself busy. Because I am as curious as you kids are. I love where we can use
how it works.
Okay, see here.
Link of this.
Here disc is say 3 discs, okay, and pegs are also 3. Are you able to see it? Get solution. Now you look, beta. Here you can see how it moves. Get solution. 1 minute. It moves. It shows solution. Yes. Here you see one disc. Then this one goes to another top. Are you able to see the animation here? This is with 3. Now the smaller one will go back than this.
In that same link, I saw another one where you can move the pegs on your own.
Yes,
and like
pegs, yeah, this is great, but this is just the possibilities of computers. You know, today, this is the right and the best time to learn. I am an engineer, I am not a mathematician, but I love these concepts, so I explore.
I think you got mistaken, I think. I meant to say that, for example, I have 3 rectangles. Let's not say circles. I have 3 rectangles.
Okay.
I put them on one side, on one
okay,
position.
we start again. See, 1. The larger one cannot be placed on the top of smaller one, whether they are triangles or rectangles, whatever shape. It can only go over a bigger one. That one.
Okay, so I did not move all 3 of them to another peg. I just moved the biggest one to the 3rd peg.
No. All 3 have to be the same position where you started.
Yes, sir. I did it in 7 moves, and I did it to the last peg.
And how many did you use? Discs for?
3 discs and 3 pegs.
3 discs and 3 pegs in how many moves?
7.
That is perfect. 7. Shall we start with 4 moves, 4 discs? See, here we are using with 4. Let us say how many. This is combination, the permutation and combination and all these possibilities. Now, and I am giving you this link here. In the chat box, you can keep playing with it. In the chat box, check here. I will enter here.
Tower of Hanoi.
Tower of Hanoi. This particular setup is called it is called by 2 names. One, they call it Tower of Brahma. This one, it is called Tower of Brahma or Tower of Hanoi.
सर मैं कौन सा लिंक खोलूं, पहले वाला लिंक या दूसरा वाला लिंक?
No, कोई सा भी आपको जहां खेलना हो, you can continue playing with it. और actually करके देखो इसको. Actually you do it.
Here's a link.
In the chat box. Check in the chat box.
Yes,
it
sir.
is there.
Yes, sir.
Oh, it is time. 1 minute. Now I will show you the thing that I did on Excel. Here. You see here in the Excel, this is the basic thing. If any of you uses Excel or can make this calculation, it is fairly simple. This is, can you see here? Is it visible? One move. Okay. One disk in one move. Two disks, three moves. 4 disks, 15 moves. And you see the formula here. You see the formula here. You see here? 2 raised to the power number of disks. If you are using 4, then I have 2 to the 2 multiply 4 times. This is the formula here. 2 raised to the power n. That is 2 into 2 into 2. See, if you want to do check with 2, then multiply 2 times and take 1 away. Right? 3. You multiply, see, for 2, how you will calculate? 2 multiply 2, 4 minus 1. And for 3, you take 2 multiply 2 minus 1. Right? You get the idea? How do you calculate this? For 3 disks, you multiply 2 multiply 2 3 times. 2 2s are 4, 2s are 8, minus 1. That is 7 moves. This is how it is coming to. Now you are deriving your formula. For 4, 2 multiply 2 multiply 2 multiply 2 and less 1. So this is the formula. With 5, it is this much. Then I have minutes, hours, seconds, weeks, decade, and century.
Oh, I see this.
You see it there? I have not even, see, if this kind of a thing is there and Shashwat say, I don't even show it to him. I alone will have fun. If he shows any interest, I will show it to him. This is how mathematics or any learning should happen. If you are interested, then you follow up like that. Okay? 1 minute. There is some sound coming from one of the microphones here. Okay. So this is why I am showing you this the Excel sheet is, so you know the possibilities and you get encouraged to learn it. See how many times you will multiply 2. So
Okay, sir. Thank you for the advice, sir.
okay, bye. We are also closing now. This is 1. Now you see, once this is done, you are only dividing it. Then you multiply, and then there is this last. I am even able to convert numbers into words in Excel itself. And you must be wondering, this guy is terrific. He knows all the numbers. I cannot even remember it. See, Excel is reading out to me what is the value in words. See here, the last number. Here it is 64. 64 disks, okay? $64 disks, and the total years are this much. And I can convert it to words. Here, 584,942. You can convert it to words. So this is a basic, the very important, calculator for us. This way. So you can play with these animations and get to know how combinations can be useful in your life. There would be many applications. You can find many applications. I can only introduce you to some concepts, but basically the applications you will have to find your own. So now this is one thing, and what we will do next time is we will build more on it, this permutation combinations and little bit of probability. These two we will do. Now, how much time we have away? I think we are over time now again.
We have just a second. Yes, the time is over now.
Okay, koi baat nahi. So these two things I can leave you with. And one more thing, I will give you one link in Wikipedia where there a lot of information is there. In Wikipedia, I am entering. One minute, I will stop share. Chat. This is Wikipedia link. So if you find time, you can explore further. Chat. This is Wikipedia link. Wikipedia is a very good research tool. So see, what we are trying to do is basically making a way for ourselves. You don't have to go to library and get the books. Wikipedia is the library for you. Here you will get all the information. Some of the information you will understand with your given knowledge.
Free library. Free library.
Yes, it is free. And some of the information you will understand, but then you will get interested in applying in your life. And next class, we will do more combinations and we will do something else in next class. Okay?
Bye.
Chalo. Okay, beta. One more thing. Abhi.
Sir, what?
Abhi. This guy brought some crabs for you from the sea. Where are the crabs? Show it to them and we will close the session.
I want to see the crab.
Crabs?
We go to the sea. Now because of Corona, we were not going out. So we go to the sea beach in the morning. And there are a lot of sea animals wandering about.
How did you catch it? Like, how?
Catch it by hand.
How did you catch
I know, but like, once you caught it, what did you put it in? A box?
We did not fry it.
No, not like no.
In the sea water. We brought sea water from there.
Just a second, I will show you. Where is the flip? Camera flip.
See, he
there
has
it
made
is.
an aquarium for himself.
Oh my. Oh my
Where is the
goodness.
crab?
Crabs. Don't they bite?
There is a small insect
Did you
too.
put a cucumber
Like this.
there?
Oh my god.
Now he is doing research what crabs eat. So somebody on YouTube, there are stupid people. They say crabs eat potato chips. They are feeding. My goodness. And he is reading there and feeding them potato chips.
But don't they bite? Don't crabs bite? Or with
They,
their pincers or do something?
they have this gripper, but if you go grab them from the back side, fine.
Crabs eat potato chips. See, I will see it runs.
And
See, I will.
there are nautilus shells, small ones, beautiful.
In fact, crabs do eat potato chips. His pet crab
Where it is?
said, I also keep pet yes.
I don't know. You flip it around first and then take it. If you flip it around, it will not.
Sir? Sir?
Is it showing?
Yeah, wow.
Crabs before.
And then
Oh,
show them this.
these are not delicious.
Nautilus shells. No, it should be zoomed.
Oh, I baby crab. I think it is baby crab. Oh, I also keep
Did the nautilus shell fell? No, I have zoomed in the camera.
ये शंख है.
That's a crab?
No, it's a shank.
Oh.
Nautilus shell. I will get the one out.
And this nautilus shell has a lot of geometry in it. Huh? We will do this.
I have a smaller one also.
We will do this exercise of how the nautilus shell develops in this conical fashion.
Oh Oh my.
It is a baby crab, very small.
What is it eating?
If you people here if you go to supermarket, there are live crabs available. If you go to restaurant, they would keep live crabs and they would cook it for you on demand right now.
Live?
This place they will keep loving it.
I should mix
Now we
them
will
some
return
air
it
so
to-
they can live. I
Chalo.
have a baby wood louse in my bag. Bye. It fell down.
Okay, bye. Now we will close. Abhi, we close now.
Yep, I'll just turn off the camera.
This is what we were thinking. Now imagine the
And
crab.
these sort of crabs.
Yes.
I
We will
see
return
them
this
inside
crab
it.
to the sea. Okay. When the crab goes back to his home, he will tell stories about us, right? This crab, we plan to return it to the sea in the evening. After the class, we will return. We will go grab fresh crabs, new ones. Now we will go back and start telling stories about us. Two monsters came in the morning. They grabbed me from the backside and put me in a bottle. And then they gave me a ride in a something called car. And then they took me home. Then what all you did with these crabs? They will tell all the stories. They will write books about us.
I ate a new food called potato chips.
And that they fed me terrible things. Potato chips, they called it. And they were making videos. One was a big monster, one was a smaller monster. And there was a Rakshasni also. No Rakshas they. And when I told Rakshasni, my wife was like, huh? भाई जब crab story बनाएगा तो ऐसे ही बनाएगा ना. Now you sit back and imagine yourself as a crab and think what story one would write. Has anybody read Metamorphosis here? There is a book called Metamorphosis. It is a book where a man turns into an insect and then he views the world as an insect. It is a beautiful book. If you have time, read it. Imagine yourself as a cockroach and you are viewing the world, your brother, your sister, your father, your mother, everybody as an insect.
No, not cockroach, butterfly.
Whatever. And then you view the world from the insect point of view. It is a beautiful book called Metamorphosis. Read if you have time. I enjoyed reading it thoroughly. So now the crab will go back. Now you plan to send it back to sea, right?
Yes.
We will drop it back, give it a ride back, and then grab another fresh piece of fresh crabs. We don't want to hold them. And anybody read this Red Chief book? Red Chief? No, Red Chief no. There was a story of a 10-year-old boy. He was kidnapped by. Yes,
Yeah, I
he
know
was.
that.
He was kidnapped by some people, and he makes their life miserable.
Yeah, he tortures each and every person in
He
there.
tortures them to no end. He puts boiled potato on his back and just smashes it. And at the end, those two kidnappers, they take him home and pay his father to take him back.
Take him back.
The next time that you kidnap, you should give the kidnapper such a bad time that you get money.
So this is what I was telling him. For the crab, we are kidnappers. We kidnapped the crab. Right? We kidnapped the crab. So we are going to return. And if you have time, and in Red Chief, it is on YouTube also. They made a movie also.
Yes, sir. Like it's like the boy asks all silly questions to the kidnappers. Why do you go to school? I don't like to go to school. Why I
Yes. And the best moment is when they take him back to his father and say, please take him back. And the moment they get rid of him, they run away like anything.
You put boiled potato on the back and smashes so much.
If you have time, read this Red Chief. It is a beautiful by Henry. O. Henry, right?
Oh, Henry, yeah.
O. Henry. I have a book in PDF form. It is available everywhere on internet. It is awesome.
Can you send it on WhatsApp?
I
It's
would.
actually not a long story, it's a short story. Like about.
It is in, like Amar Chitra ka tha, like that. Carry in that form, in story form. It is a beautiful book. I will share it with you if you have time. So now we are the kidnappers of that crab. But we will return
Yes.
it. To kidnap those, we will return it.
But you will not give money to the
No.
crab.
I plan to eat it in fact. When I was in Greece, the seafood was great. In my family, all are vegans. Nobody, they are all vegetarians. I am the only spoiled one. And when I was in Greece, the seafood was great. And these crabs they taste delicious. But when I tell him this, he said, nowhere, you will not touch my crab. He is ready to fight for the crabs, huh? But I am not going to eat your crabs. No problem. There is nobody here who can cook it. Who will cook? Your mother will not cook.
You can cook. You can cook.
Yeah, you cook the crab.
I don't know how to cook. I only know how to boil eggs and make tea. That's all. I have to take this crab to my Greek friends. They can really cook.
Yes, and
Return to its mother now.
it doesn't
We will go
exactly matter. If you want to keep them for a longer time.
No, we will not. If they are around for a long time, I would be tempted to eat them.
Now, when we are going to return them?
We would return the crabs.
But when?
Now, we are going now.
Just recommending it.
No, we will return the crab. We are kidnappers of the crab only for 4 hours. We would return the crab.
Grab some fried shit.
Tomorrow we will go grab some fresh crab. Now we are returning.
Fresh crabs every day.
Every day fresh crab. Like
It's
in the morning we go.
actually a convenient idea. These crabs might get.
You find a big crab, no, the bigger one.
Yes.
It
बेटा
ran
जिस दिन
away.
उसने पकड़ लिया ना नचा देगा काट देगा वो
Don't-
his Facebook profile there he keeps now he is into not mathematics, he is not into science, he is not into anything, he is into cameras. Cameras, movie making, dialogue delivery. He has made me into an actor in his films. Keep the camera like this, keep the camera like this. He is learning videos now.
You should
Now
make
next,
a
this says
5:30 a.m. vlog that we are going to the beach. See, we are catching a crab.
so this is what he is into now.
A video on the
Camera handling is now very good.
Yes,
I
he's
can-
learning. He is into movies now, audio videos. Mathematics he doesn't learn now.
You're keeping
Plastic crab to attract other crabs. A big one.
Yes, a plastic crab. Plastic crab.
We take it to the beach and put
Just
the
a second,
plastic
I will
crab.
Get attracted? Do they get attracted to the plastic crab?
They are just roaming around. You know, it is a low tide. When it is low tide, the sea goes back. When the sea goes back, there are puddles of sea water and they get stuck there. And you can grab them. If they are in open sea, you cannot grab them, not possible. They run so fast. You cannot catch them. But they are stuck in a puddle of water, sea water. Till the next tide comes, that only will take. But before the sea tide comes, we monsters come and grab them. Okay, Vital. Next time we will do something about this combination theory, and also we will do some probability. You do one thing. We will relate it to our life experience. So have fun. It is pleasure talking to you and being with you always. Thank you. Thank you. Have fun. Okay. Bye. Bye.
Bye. Bye.
Bye.
Bye.
I'm looking for all.